All right, so when we're running these tests, we can either use rejection regions or p-values when we're doing this hypothesis testing. We're just going to do p-values in this video and in this lesson. It's generally more popular when you're looking at research journals. Rejection regions still work, but you're more commonly going to see p-values. So we're going to calculate our p-value. Remember, a p-value is the probability of getting something that extreme. So if we say, we think that we believe that 89% of voters in Williams County vote Republican, and then we do our test and we find in our sample, we find that maybe 93% of people claimed. We want to know, okay, if this is true, what's the probability of getting something that extreme? That's the p-value, the probability of getting something that extreme. And then we decide, okay, compared to our level of significance, are we going to accept or reject? If our p-value is less than our alpha, we're going to reject the null. So if we had said, okay, we're going with an alpha of 0.05, if the probability of being this extreme is less than this number, we're going to reject. We're going to say, this probably isn't true then. If our p-value is greater than a, if we get a p-value of 0.12 or something, we're going to fail to reject. We're going to say, oh, this value wasn't that extreme. It might have just been by chance. Same rules that have applied in the rest of Chapter 10. So let's do an example. The local school board has been advertising that at least 65% of voters favor a tax increase to pay for a new school. A local politician believes that less than 65% of his constituents favor this tax increase. To test his belief, his staff asked a simple random sample of 50 of his constituents whether they favor the tax increase, and 27 said they would vote in favor of a tax increase. If the politician wishes to be 95% confident in his conclusion, does this information support his beliefs? Okay, so that's what we're working through. All right, step one in our hypothesis testing is we need to write our null and alternative hypothesis. All right, our politician is claiming that less than 65%. So he is saying, look, the proportion of voters who are going to support this tax increase is less than 65%. The opposite of that, our null hypothesis, is that it's greater than or equal to 65%. All right, step two. Since we are dealing with proportions, not means, we are going to use a one proportion z-test. At alpha is 0.05. We need to make sure we meet all the conditions for this. So we have a simple random sample. They're independent. You're just asking these people. Either you support or you don't, so there's only two outcomes. And we need to check if our sample size is large enough. So we need to check NP, and we need to check N times 1 minus P. So this politician is asking 50 people, and P is 0.65, and then 50 times 1 minus 0.65. Pop those numbers into the calculator, and we get 32.5 and 17.5. Okay. Both of these values are greater than or equal to 5, so we're okay. This will work. All right, step 3. We are going to calculate our test statistic. So step 3. This is where we're going to use that formula from the other side of the notes. That z is p hat minus p over the square root of p, 1 minus p over n. All right, remember p hat comes from his survey, his sample. So he found it was 27 out of 50 supported this. So 27 out of 50. P comes from the null and alternative hypothesis, that's 0.65. And then we have P again, 0.65, 1 minus 0.65, and N was 50. I'm really running out of space there. All right, be really careful plugging that all into your calculator. You'll definitely want to put the entire numerator in parentheses, otherwise it's not going to work out right. And when you do that, we get 2.25 as our z-value. So now that we have that, we need to put it all together and make some decisions. So here's step 4. All right. We have, that's not right at all. I put the wrong z-value down. I apologize for that. That is negative 1.63. I was looking at the wrong problem. Okay, let's try again. So negative 1.63, this is where we're at, our z-value. And from over here, we are running a left-tailed test. Okay, so we are looking down here. We want to know what's the probability of getting a value that extreme. Okay, so that's what we're looking for. Our p-value is the probability of getting a z-value less than or equal to that. Okay. You can do this by looking up on the table. It's the first big table, I think table A in your yellow packet. It's area to the left of the curve, so you just look up negative 1.63 and it tells you that. You can also use your calculator for this. This is the normal CDF, and you'd be going from negative infinity to negative 1.64, mu is 0, standard deviation is 1. Either way you do that, we end up with a p-value of 0.0516. And you could get a slightly different number depending on if you use the table or your calculator, so you're aware, but it should be like within 100th or 1,000. They'll be very close. So now we want to compare this to alpha. So our p-value is 0.0516 and our alpha was 0.05. So our p-value is greater than alpha. So in that case, we fail to reject. Okay. I'm not going to write out the entire interpretation, but I would say something like, at the 0.05 level of significance, the data does not support the politician's claim that less than 65% of constituents favor a tax increase to pay for the new school. Okay. So if we fail to reject this, we have to accept the null, that it looks like there is higher than 65% of people who are willing to pay this new tax for the new school. Okay. As always, I encourage you to read the book and read how they interpret stuff, because you do need to write that down. I'm just really running out of space. We'll check out one more problem in the next video.